In its search for new drive technology, the Imperial German Navy discovers a maverick. His life's goal is to create a revolutionary engine, a machine he hopes will serve humanity and eliminate poverty. He conducts risky experiments and captures the interest of powerful people, until the day he vanishes without a trace. This was Rudolf Diesel and the engine that would move the world. It's autumn 1913. A fishing boat lowers a dinghy into the sea. The men have spotted something gruesome. It's a corpse, one that may put an end to speculations about something potentially scandalous. A story that's making headlines across the globe. Renowned German engineer Rudolf Diesel's disappearance somewhere in the English Channel. Rumor has it that it was murder. 10 days prior, the ferryboat Dresden plows through the night en route to England. One of the passengers is the prominent and very much alive German engineer. Diesel has created world-changing technology that's managed to make him some enemies. He's heading for England to open an engine factory, a project viewed with suspicion in Germany, with war looming on the horizon. No one notices anything odd as Diesel bids goodnight to his business associates that evening and retires to his cabin alone. But when Diesel fails to appear in the morning, his colleagues are concerned. They fear he may have fallen ill. But his cabin is empty. It's quickly obvious that Diesel has not been to bed, nor has he even opened his suitcase. A search of the ship turns up nothing. Rudolf Diesel is gone. "21 years prior in Berlin, a spirit of optimism reigns. Kaiser Wilhelm II has ambitious plans. He's eager to do whatever it takes to make Germany a world power. Industry appears to be on the upswing, but faces one serious challenge. The steam engines used in production consume mountains of costly coal. In over 100 years, no one has succeeded in developing a more efficient engine. Industry and the military search frantically for a new design. The advent of the steam engine has taken a heavy toll on German workers, putting many tradesmen out of work and driving them into poverty. Only the wealthy can afford steam engines. A young engineer, Rudolf Diesel, wants to change that by building a new type of engine that's widely affordable. It has become his life's mission.
His way of thinking was to address social issues and to help workers. For someone from the bourgeoisie, as most engineers were, that was quite rare.
Diesel actually came from a modest background. He's all too familiar with the difficult conditions the workers face. Diesel is convinced his idea will make the world a better place and works to the brink of exhaustion, designing his engine. It should be small, easy to handle, and above all, inexpensive. More powerful than any other engine in history. But the grueling pace soon takes its toll. Diesel is plagued by piercing headaches, eased only by strong medication. Warning signs Diesel ignores. his mission overrides any personal health concerns. His wife Martha cannot convince him to rest. Diesel fears that wasting time could jeopardize his grand vision of ushering in a new machine age. But even Diesel's wildest ambitions for his invention likely pale against today's reality. The diesel engine has become the backbone of our global economy, propelling giant cargo ships across oceans. Every one of these mighty machines produces enough energy to power 20,000 households. Over 58% of the world's goods are transported by ship. This would have been impossible without the invention of the diesel engine at the end of the 19th century. Berlin, 1892, inside the German Imperial Naval Office. It's a secret meeting to discuss the Navy's future and a far-reaching mandate from Kaiser Wilhelm II. He wants to build a German battle fleet formidable enough to defy his most powerful rivals. It's not long before Rudolf Diesel's work comes to his attention. Just a few kilometers from Imperial Naval Headquarters, Diesel explains the theory behind his engine to his son. His approach is something new. Using compression, air in the engine is heated several hundred degrees. Diesel believes that fuel injected into this air will ignite automatically. He got the idea by studying a common fire piston. A piston plunged inside a cylinder containing fuel concentrates air, and that compression heats the air, lighting the fuel. Diesel hopes higher pressure will make it possible to ignite any fuel. But skeptics reject the idea out of hand, arguing that materials that can withstand such pressure simply don't exist, or they question the very idea of fuel injection.
Diesel was attacked from all sides. They all said his engine couldn't work. They called him a fraud, and those attacks really angered him.
Other inventors had tried replacing steam with gasoline engines. But such engines had limited use and cost a small fortune. One of the largest engine manufacturers is the Cologne-based company Deutz. Professor Otto Kühler was one of the company's consultants, and he would soon become Diesel's bitter adversary. He, too, has been working on a self-igniting engine. Like Diesel, he's tried to solve the fuel injection problem, but without success. Experiments performed by modern researchers demonstrate the issue both Diesel and Kühler once grappled with: the need for precision ignition in the combustion chamber. Fuel injection was the key to the design of the diesel engine. The timing of the injection must be calculated to 1,000th of a second, using an equally exact measure of fuel, only a few drops for an automobile engine. To work, the injection must deliver the fuel as a fine mist. Technology is always improving. Developers refine the modern diesel engine with ever more precise measurement techniques. But they too can hit roadblocks.
Even with computerized methods today, we still can't make exact predictions. So we must rely on combustion chamber tests and other procedures, just as Rudolf Diesel did back then.
The self-igniting engine can perform far better than all other combustion engines. But in 1892, Rudolf Diesel faced untold obstacles on the road to its invention. Despite unresolved design flaws, Diesel writes to dozens of companies. He needs investors so he can build a prototype, but he's rejected at every turn. His last hope is Heinrich von Butz, director of the Maschinenfabrik Augsburg. Butz asked his senior engineer to review Diesel's construction plans. He knows that replacing the old steam engines could save him a bundle. But the man's report is scathing. He says Diesel's idea is a pipe dream that no engineer on Earth would get behind. But Butz decides to think it over, despite the warnings that the project is unfeasible. Diesel gets more bad news from the German Patent Office. He's denied his on the grounds that patents exist for similar engines. By reworking his application, Diesel contrives to secure one anyway. A patent is granted, and Diesel now believes he's the official inventor of the self-igniting engine. A serious error. Years before, Otto Kühler of the engine manufacturer Deutz had published an article on his own idea for a self-igniting engine, an idea he never pursued further. Kühler is unaware of Diesel's research or his claim to being the engine's inventor, but he'll hear about it soon. Meanwhile, Rudolf Diesel anxiously awaits a reply from Maschinenfabrik Augsburg's director, Heinrich von Butz. Butz had initially shown great interest in his idea, so when his letter arrives, Diesel is counting on his support. Instead, the reply is crushing. No material can withstand the pressure required for your engine, Butz writes. Diesel is aware of this flaw and already has an idea that he hopes will make Butz reconsider. And soon thereafter, he receives positive news. Butz's second letter accepting Diesel's proposal can be found today in the Deutsches Museum in Munich. The archives contain Diesel's life's work, a wealth of unpublished research, photographs, and letters. Diesel scholar Ralf Spicker searches for Butz's second letter. But this one doesn't reveal exactly how Diesel persuaded Butz to finance his project. Another letter is more explicit. Diesel offers an intriguing solution to get Butz to change his mind, lowering engine pressure to a fraction of his initial calculation. It was still greater than any machine had previously handled, but to Butz it was possible, at least in theory. One thing Diesel never shares is that he still has no idea if the engine will self-ignite. Researchers have since solved the mystery of the minimum compression levels required for self-ignition. In so doing, they made an astounding discovery. Diesel had hit on the exact figure with his last-minute calculations. His initial numbers had been far too high. Today, every diesel engine undergoes rigorous testing, like this marine engine analysis. The overload test is very important. The pressure is raised to 10% over maximum capacity. Such tests use cutting-edge technology, computer calculations, and simulations. By comparison, Rudolf Diesel had only the most basic tools to rely on. Butz has agreed to build Diesel's prototype engine on the condition that he find another backer. Diesel quickly writes a book touting the merits of his engine. He hopes it will win the financial support he needs. The entire project is riding on his success. Diesel receives an invitation to Villa Hügel, the residence of the powerful Krupp family. They'd been impressed by the groundbreaking ideas he'd published. Suddenly, the once beleaguered Diesel has the ear of the most powerful industrialist in Germany. Friedrich Alfred Krupp.
Krupp led him through his library and onto a balcony that overlooked the park. The balcony had 2 chairs and a table. Krupp's first words were, "The Kaiser was the last person to sit in this chair."
Many of Krupp's top managers warn against taking such a leap in the dark. But Krupp gives the green light, sensing that Diesel's engine has enormous potential. He signs a contract with Diesel and Maschinenfabrik Augsburg. Construction of the prototype can finally get underway. Diesel returns home in high spirits, his dream of improving the lot of German workers finally within reach. But nearby, other plans are hatching. Kaiser Wilhelm II is searching out any technology that will help turn the German Empire into a superpower. A surge in arms spending is already making millions for Krupp. And the innovation-minded Kaiser has also read Diesel's book. Such an engine would be a great asset in realizing his most ambitious project, turning his navy into one of the world's largest by building a massive battle fleet more powerful than Great Britain's. Replacing steam engines with this new technology would make it possible to do away with boilers and coal bunkers, fixtures that take up a lot of cargo space. Diesel's engine would require less space and would also increase the cruising radius of the warships. Diesel's book is also making waves elsewhere. Deutz engine consultant Otto Kühler has read it. He thinks Diesel's ideas look a lot like the ones he'd published much earlier. Has Diesel managed to solve the production issues? It's doubtful, but Kühler decides to keep an eye on Diesel's progress. Diesel still has no clue what an impact his book is having on the military-industrial front. His focus is on one thing only, building his prototype in Augsburg. But it's going to be a huge challenge. Now he must prove he can actually build an engine that can withstand more stress than any other before it. It's a feat that engineers everywhere deem impossible. Changwon, South Korea. The largest diesel engines in the world are built here. Production on this scale is complex, even with the most advanced technological means. This engine will propel a ship with an output of nearly 100,000 horsepower. Power that must be well harnessed. This is one of the trickiest stages in construction. A crankshaft will be mounted on the engine block. The engineers call this critical step the marriage. This 30-ton crankshaft will run at 100 RPMs inside the engine. Only the hardest steel alloys can withstand such stress. The crankshaft is over 20 meters long, but the engineering tolerance is only around 1/10 of a millimeter. The tiniest flaw in production or assembly would have major repercussions when the engine was started. An automobile diesel engine has a life expectancy of up to 5,000 hours. But this marine engine is expected to operate 6,000 hours per year. No other engine is as intricate to build. No machine demands so much from its components or poses such enormous challenges, even for today's engineers. August 10, 1893 is a fateful day for Rudolf Diesel. Many have come hoping to watch him fail. Today marks his first attempt to fire up the engine. His future will depend on what happens in the next few seconds. he wants to show all the doubting engineers that his invention works. A steam engine drive belt brings his engine to idling speed. Months of work are all coming down to this. Next, it's time to ready the fuel supply on the motor that the men mockingly call Diesel's Black Mistress. Then, it's the moment of truth. What initially looks like failure is actually the exact opposite. The minor explosion proves that the engine did indeed ignite. Diesel's theory is sound. He declares with confidence that mass production of his engine is only a mere few months away.
Der Motor war nach der ersten Zündung längst
The
noch
engine
nicht
was far from
betriebsfähig, musste
operational.
noch mit
It
angetrieben
needed an
werden,
external
überhaupt
drive to run it
zu
all.
laufen. Und
Diesel
Diesel
probably
hat
overlooked the
wahrscheinlich
fact
so
that he
übersehen, dass
hadn't
er
managed
eigentlich
to
noch
reach
nicht
his
am Ziel
goal
ist,
of
nämlich
building a fully
einen rundlaufenden,
functioning engine.
betriebsfähigen Motor zu haben.
It's chaos in Augsburg. One morning, as Diesel arrives at the factory, workers and engineers are fleeing the plant. His engine has overheated. It's been months since the first ignition tests. All new attempts have failed. Dangerous accidents occur almost daily. The men urge Butz to put an end to these risky experiments before Diesel's engine kills someone. Diesel refuses to give up. He's convinced he'll solve the problem soon. But he also knows that the engineers are losing patience and that Butz's support has its limits. If he doesn't produce results soon, he can bury his dream of building his radical new engine. Nearly 120 years later, a newly designed ship engine rolls out of the factory where Rudolf Diesel once fought for his invention. More than a year of thorough testing goes into the conceptual phase of engine design using the latest high-tech tools. Simulation software helps detect technical flaws early. Engineers then spend 2 more years working out all details before a prototype is approved for testing. And measurement technology determines its intricate final assembly. No matter how finely calibrated the engine, only a trial run can determine whether or not it will function properly. Exactly the same as in Diesel's time. Rudolf Diesel checks and double-checks his blueprints, making endless adjustments to the engine. Still, it fails to run on its own, relying instead on a drive belt from a steam engine to keep it operating. Finally, he prepares a new test. Butz wants results, and time is clearly running out. Diesel has re-engineered every part of the engine and devised a high-pressure fuel injection system. The initial test readings are promising. Diesel believes he's finally on the right path. But when he tries to explain what comes next to his mechanic, there's total silence. The man stares at the drive belt as if spellbound. Others soon realize what's happening here. The belt has slackened, which can mean only one thing. The engine is running entirely on its own. Diesel has done it, proving beyond a doubt that a self-ignition engine is indeed achievable. The stock exchange goes wild over the news. Shares in Maschinenfabrik Augsburg skyrocket beyond all expectations. engineers and entrepreneurs from across the globe visit Bavaria to witness this technological marvel and meet its inventor. But a phone call cuts short the celebration for Diesel. Another engineer intends to challenge his patent. Diesel is beside himself. He spent half his life on this invention. Now someone wants to dispute his claim? Diesel's already poor health worsens. A patent lawsuit would delay production of his engine for years.
Herr Diesel?
Diesel arranges a secret meeting with his rival. It's Otto Kühler with Deutz engine manufacturers. Diesel tries to persuade him that he alone had come up with a way to build a functioning self-ignition engine. All Kühler had done was describe an idea. But Kühler won't back down. Diesel is getting nowhere, so he makes him a generous conditional offer. A consultancy contract of 3,000 marks a year if Kühler drops the idea of a patent lawsuit. It's an offer his rival can't refuse. Now nothing stands in the way of his success. Diesel travels the world to license his engine. Industrialists scramble to sign on. And Diesel is a millionaire in no time. Others in high places also have designs on his invention, but as yet no access. The push for naval expansion continues in Germany. Naval engineers wish to acquire Diesel's engines for their fleet. But Diesel rejects all such overtures. He's determined to keep his invention out of military hands, which does not sit well with the authorities. An engine designed for commercial shipping is Diesel's goal. To succeed, he needs an alternative to the costly petroleum it currently runs on. A marine engine would consume vast quantities of fuel. Getting it to run on an oil with a high flash point would make more sense. His engine would be profitable for shipping if he could get it to work on cheap oil industry waste. Diesel's piercing headaches are getting worse, often forcing him to break from his work. His assistants conduct many of the tests for him now. Results are excellent. Thanks to the engine's compression tolerance, heavy oil will now burn, overcoming the most critical obstacle. The future looks promising to Diesel, well beyond his own personal gain. He hopes his engine will be a boon to humanity, inspiring other inventions to improve people's lives. The diesel engine would revolutionize shipping. South Korea, where today's megaships are built, some up to 3 football fields long. 40 such steel giants leave this shipyard each year, hauling goods across the globe for shipping companies. They all depend on the workhorse of engines, the diesel. These behemoths burn 13 tons of heavy oil an hour. If they couldn't run on cheap fuel oil, such powerful engines would never have been built, and today's container ships would never exist. Today, Diesel's wife receives troubling news. Her husband is in the hospital. Rudolf Diesel has suffered a nervous breakdown. Years of neglecting his health, extensive travel, and battling to build his engine have taken their toll. Diesel promises his wife that he'll take it easier. But he can't let go entirely as a major event approaches. The 1900 World's Fair is about to launch in Paris, promising to top all others before it. Diesel wants to win the Grand Prix. It's the fair's most prestigious prize, awarded by a jury of eminent scientists. Over 50 million visitors from across the world are drawn to Paris. Diesel's machine creates real buzz and wins the coveted prize. People agree, this is a miracle of technology. But hardly anyone notices that it's running on peanut oil. Diesel's vision is to create an engine that doesn't rely on crude oil, an idea that fails to impress the public. Mainly, people wonder why anyone would consider using vegetable oil as fuel. Rudolf Diesel was a man way ahead of his time. In his country today, rapeseed grows on 1 million hectares of land for biodiesel. The trade-off is that precious farmland is no longer available for food crops. A futuristic-sounding pilot project near Cologne may someday solve this problem. Researchers at Jacobs University are experimenting with a miracle plant. They're breeding marine algae in these bioreactors. The algae are nourished with carbon dioxide flue gases from a nearby coal-burning power plant. The microscopic algae absorb the CO2 and grow very quickly. These algae are bursting with energy, producing 20 times more biodiesel than the same amount of rapeseed, all while capturing the greenhouse gases emitted by the power plant. When the algae concentration is high enough, they're harvested. 1 hectare of algae can produce up to 30,000 liters of biodiesel. A chemical process converts the algae into oil. The hope is that aquaculture will one day be the primary method for algae cultivation, reducing our dependency on crude oil. At the start of the 20th century, the diesel engine makes new inroads. Power plants are soon driven by turbines with diesel engines. Diesel would like to capture the auto industry as well, but this market will be dominated by the gasoline engine for years to come. But the maritime industry fully embraces the diesel engine. The first diesel-driven passenger ship launches in February 1912 in Copenhagen. The MS Selandia marks the dawn of a new age in ocean travel. While in Berlin, the admirals of the Imperial Navy are strategizing. The German Navy can't keep pace with the British. England is producing far more ships. Germany has lost the naval arms race. More than ever, the Navy wants diesel engines. Not for use in their warships, but for an entirely different weapon. If Germany can't dominate the high seas, maybe it can rule the deep with its submarines. Diesel engines are clearly the best way to power these weapons. They offer the best cruising radius above water and the safest way of charging batteries on electric motors when the vessel is submerged. The diesel engine becomes essential for submarine warfare. Rudolf Diesel can no longer prevent his worst nightmare from coming true. His engine is now prized military technology, not only in Germany, but in other nations as well. Diesel's dream of fighting poverty with his invention is still just that, an aspiration. His growing frustration with political events motivates him to write another book. He argues with passion for an anti-capitalistic social order. But no publisher jumps to print his ideas on solidarity as a way of relieving humanity from economic hardship. So Diesel decides to publish it himself, though many have advised him not to. In Berlin, all signs point to war. Admirals watch footage of British naval maneuvers and discuss battle strategies. The enemy must not be allowed to access key military knowledge, which now includes the diesel engine. They've already forced Heinrich von Butz to refuse a contract for the motors with the British firm Vickers. No new engine upgrades should make their way to England. Rudolf Diesel may have made a fortune on his invention, but over time his situation has become precarious. The successful engineer has financial problems. Building a home, publishing a book, and investing poorly have all drained his bank account. His wife Martha has no idea that most of their millions are gone. At the end of September 1913, Diesel plans a trip to England. He'll attend a business meeting and the inauguration of a diesel engine plant. The headlines predict war any day now, and that worries Diesel's wife. Diesel tries to calm her. He urges her to stay with friends and promises to write often. Diesel is consumed by his need for success in England. If all goes well, perhaps he can recoup his losses. Risky, yes, to ignore the German Reich, but new British contacts are critical for business. After all, he reasons, both France and Great Britain are already clients. On September 29, 1913, Diesel crosses the English Channel aboard the ferry Dresden. He dines with business associates. Later, they would describe the atmosphere as cheerful. They laughed and speculated about the diesel engine's future. Before retiring that night, Diesel agreed to meet his companions the next morning. But he'd never make it to that rendezvous. That night, he would disappear without a trace. Ten days later, the crew of the Dutch boat Kurtzen finds a dead man floating in the sea. They've heard that the famous engineer has gone missing. But the body is decomposed beyond recognition. The captain will not allow a corpse on board, so they take only the objects they find in the man's pockets. They hope this will help authorities determine if the deceased was indeed Rudolf Diesel. One of Diesel's sons identifies the items as his father's. At first, the family is baffled by his death. But when they learn about his financial woes, they're convinced that Diesel has committed suicide.
Ich glaube nicht an einen Selbstmord, weil einfach noch zu viel Ziele.
I don't believe it was suicide. He had too many goals and plans. He wanted to relaunch his book. He wrote letters to his wife describing the trips they would go on. He wanted to retire and to move into a smaller home. He had thought about heating costs. He tidied things up while his wife was on holiday. A man planning to commit suicide doesn't do that.
Das macht einer nicht, der sich umbringt.
Many suspected that Diesel was the victim of a murder conspiracy that night aboard the Dresden. No farewell note was ever found during the investigation, and the letter Diesel had sent his wife shortly before his departure was upbeat. Critics of the suicide theory thought it was highly unlikely that Diesel would take his own life without any explanation whatsoever. And something else was off. The key to his suitcase was found in its lock, as if he'd been interrupted. Who, if anyone, came knocking at his door? To this day, the mystery of his death that night by murder or suicide remains unsolved. In the end, the motor Diesel had created with humanitarian goals became the engine for worldwide commerce. Trade on today's scale and the founding of a global economy would have been inconceivable without the diesel engine. An invention more than 100 years old, for which there is still no real alternative.
Diesel engines will power ships far, far into the future, no doubt. Whether we run them on fossil fuels or power them with renewable fuels is inconsequential. We will see this engine in commercial shipping for a long time.
New and ever more powerful diesel engines are always in development. Engineers see no limits to their future, and Rudolf Diesel would have certainly been proud of that.